Okay, hello, this is chapter 15 and we're talking about organic chemistry. So let's first of all talk about what are organic compounds. You should know that organic compounds are covalent compounds of carbon that were originally obtained from plants and animals. So all of these are the types of organic compounds that we are going to study. So organic compounds are all covalent compounds of carbon, and they're called organic. That means that they were originally obtained from plants or animals. So remember that dioxide is not an organic compound since it was not obtained from plants or animals, although it is a covalent compound of carbon. So remember that organic compounds have carbon, they also have hydrogen, and they may have other elements such as oxygen. Okay, one type of organic compounds is hydrocarbons, and from its name, hydrocarbons means organic compounds that are made up of only carbon and hydrogen. And you have to be careful that you say only carbon and hydrogen, because all organic compounds have carbon and hydrogen. They may have carbon and hydrogen and other things, but if they have only carbon and hydrogen, then they are hydrocarbons. So these are examples of hydrocarbons where you have only carbon with hydrogen, no oxygen, no other elements, and so on. Okay, we divide organic compounds into groups, but we don't call them groups, we call them homologous series. So we have a homologous series that we call alkanes. There is another group of organic compounds or homologous series called alkenes. Another group is alcohols, acids, esters. So each of these are groups of organic compounds. Now, the members of the same homologous series will have, first of all, the same general formula. General formula is the relationship between the number of carbons and number of hydrogens. So, for example, if you're asked what is the general formula of alkanes, it is CnH2n plus 2. That means that for a certain number of carbons, if we're talking about alkanes, the number of hydrogen will be twice that number plus 2. That's what we call a general formula. Now, the general formula for alkenes is CnH2n. That means that for a certain number of carbon atoms, the number of hydrogen atoms will be twice that number. So each of these series or each of these groups has a certain general formula, but you are required to know the general formula of alkanes and alkenes. Now, each member of the group also has the same functional group. Functional group means the part of the molecule that identifies the series we're talking about. So, for example, how do I know if something is an alkane if all the carbon-carbon bonds are just a single bond? How do I know if something is an alkene? If one of the bonds between the carbon atoms is a double bond. Remember single covalent bonds, double covalent bonds? An alkene will have a C double bond C. An alkane will have a C single bond C. An alcohol will have somewhere in the molecule an OH. Only an OH. The rest of it will be carbons and hydrogens. Now, if it has OH and C double bond O, then it is an acid. Can you see the difference? If it has a C double bond O and then an O but not attached to an H, that's an ester. Okay, so all the members of the same homologous series have the same general formula, same functional group. Since they have the same functional group, then they will have the same chemical properties. So all alkanes will have certain chemical reactions, all alkenes will have certain reactions, and so on. They will differ in only the number of carbons. So some of them will have 1 carbon, 2 carbons, 3 carbons, 10 carbons, and so on. But they all have the same general formula, same functional group, same chemical properties. So if you have a question like this, you will probably be asked what is meant by the term hydrocarbon. Do you remember from what we said what is a hydrocarbon? A hydrocarbon is an organic compound containing carbon and hydrogen only. The word only gets the second mark. State 2 features of a homologous series of compounds. We said Homologous series of compounds will have the same what? They will have the same general formula, same functional group. That's the most important thing. Okay, then you will be required to name organic compounds. So in order to name an organic compound, first of all, find out what is the number of carbons in the chain, then determine which functional group we have, and then you include branches counting the carbons from the side that is nearest to the functional group. What does that mean? It means, first of all, you need to know that anything that has one carbon, its name will start with meth. 2 carbons, its name will start with eth. 3 carbons, prop. 4 carbons, bute. 5 carbons, pent. And then, is it methane or ethene or propanol or butanoic acid? That will depend on, does it have only single bonds between the carbon, or does it have a double bond somewhere, or does it have an OH somewhere, or does it have a COOH somewhere? Okay, so let's try naming some organic compounds. So for example, you have this and you're required to name it. So the first thing you're going to do is how many carbons. Remember we said 1 carbon meth, 2 carbons eth, 3 carbons prop, 4 carbons bute, 5 carbons pent. Meth, eth, prop, bute, pent. This is which one? This one has 2 carbons, so its name must start with eth. Now it's going to be eth what? Is it ethane or ethene or ethanol or ethanoic acid? Well, it has an OH. It has an OH, that means it's an alcohol, and all alcohols will end with ol. So this is called ethanol. Do we understand that? Let's try naming this. Again, how many carbons? We have 4 carbons, so the name must start with bute. Now, what does it have? Single bond, double bond, OH, COOH? No, it has a double bond, then it's an alkene. So this is called butene. Now, if you want to be specific, you need to mention where is the double bond. Now, the double bond is after the first carbon, so I call it 1-butene or but1. Okay, let's try another one. How many carbons? 2. So the name must start with eth. Now, it has what? It has only single bonds between carbons. That means this is ethene. Again, let's try this. How many carbons? 1. So the name must start with meth. And then what does it have from the functional groups? It has a double bond O and OH. So that's an acid. Acids are called something oic acid. So this will be methanoic acid. Do we understand this? Okay. Again, let's try another exercise. This is very important. How many carbons? 4. And we said 4 carbons. The name must start with bute. Which functional group? Only single bonds. Then this is called butane. Another one. Which one is this? This is 2 carbons. Eth, a double bond. That means it is ethene. What about this one? 1 carbon, meth. It has an OH, so it is methanol. What about this one? How many carbons? 2 carbons, so that's eth. Now it is eth what? It is ethanoic acid because it has the functional group for it. Okay, do we understand naming? Okay, let's try looking at the types of formula you will be required to draw. So you will be required to draw displayed formula. A displayed formula is one that shows the arrangement of all the atoms in the molecule. So for example, if I'm told to draw ethanol, the first thing I ask myself, how many carbons? Eth means 2 carbons. Ol means it has an OH somewhere. Now, if I draw it like this, with all the bonds between all the atoms, this is called a displayed formula. Now, what if he asks me to draw the structural formula of ethanol? Now, structural formula shows the arrangement of the atoms grouped together. So instead of writing the C with all the H's around it, I just write it as a CH3. Now, the other carbon has 2 hydrogens and an OH, so writing it in this way, this is called the structural formula. Now, the molecular formula, this is what we already know. The molecular formula is the one that shows the actual number of each element in the compound. So this will be, I have 2 carbons, 6 hydrogens, 1 oxygen. So my molecular formula is C2H6. Do we understand the different types of formula? Okay, isomers. Isomers are 2 or more compounds having the same molecular formula but different displayed formula. What does that mean? If I'm required to draw isomers of propanol, first of all, how do I draw propanol? Prop means 3 carbons, all means an OH somewhere. Now, my question would be, where am I going to put the OH? Is it at one end of the chain? And remember that whether I put it on the last end of the chain or on the beginning of the chain, it is exactly the same molecule because molecules are 3-dimensional. So if I put it on the last carbon, this is exactly the same as the first carbon because you can just turn it around. Now, the other way of putting the OH will be somewhere in the middle. So I have 2 options. I can either put the OH on one end, either there at the end here or the end or the other end, or I put it in the middle. Now these 2 compounds have the same molecular formula. They have the same number of carbons, same number of hydrogens, same number of oxygens, but they have different displayed formula, so they are called isomers of each other. So these are called isomers of propanol. So let's try to draw isomers of butene. Now again, how do I draw butene? But means 4 carbons, ene means a double bond somewhere. Now, we said I can either put the double bond on one end, again, it's either on this end or the other end, or I can put it in the middle. Now, these 2 have 4 carbons, 8 hydrogens. They have the same molecular formula, but they have different displayed formula or different structures, so they are isomers. Remember, when you are drawing any of these molecules, each carbon atom must have a total of 4 bonds. Remember that carbon in the periodic table is in group 4, so it has 4 electrons in its outermost shell. It needs 4 more electrons. That means it can make only 4 covalent bonds, not more. So if I have 2 with 1 carbon, then I need only 2 more hydrogens to make them 4 for each carbon. Do we understand what I'm saying? Each carbon must have only 4 bonds, or 4 lines coming out of it. Remember that each of these lines represents a covalent bond. Okay, again, let's draw isomers of pentane. So remember, when we were drawing isomers of propanol, we said propanol has to have an OH, so it's either the OH is on one end or in the middle. Now, isomers of butene, we said butene must have a double bond, so the isomers are either double bond on one end or the double bond in the middle. What if I'm asked to draw isomers of pentane? Now, pentane is something that has 5 carbons, single bonds, there is no double bond, there is no OH, but then the isomers here would be different arrangements of the carbon. So I can either put all the 5 carbons after each other in a long chain like this, or I can write it what we call branched. So instead of making all the 5 on one row or one chain, I put the 4 on one row and one of them is a branch, or I put the 3 on one row and 2 of them as branches. So these are isomers of pentane. Do we understand how to draw isomers of alkanes? Okay. Now, so alkanes in general, we said these are the ones that have CnH2n plus 2. That means that the number of hydrogen is always twice the number of carbon plus 2 more. Now, we said that the functional group of alkanes is C single bond C. Because they have only single bonds, they are called saturated. So remember, if we say why are they saturated? Because they have only C single bond C, no double bond between the carbons. Okay, and we said you can either draw this as displayed formula or as structural formula. Okay, what about the physical properties of alkanes? You should remember that alkanes with low number of carbons are gases or liquids. And then with the large number of carbons, they become solids. So anything less than 5 carbons is a gas. So methane, ethane, propane, butane, all of these are gases. Remember that butane is the one that we use in the butagaz or in the bottled gas. that we use at home or in some um, shops or something for fuel. Okay, so less than 5 carbons is gases, higher than that liquids, and then very high number of carbons would be solids. Remember that methane is the main constituent of natural gas. So the natural gas that most of us use as fuel at home is mainly methane. So what do we use that for? We use it as fuel. So don't say use of methane is natural gas. Methane is the natural gas. So what do we use that for? We use it as fuel. Okay, now the chemical properties of alkanes. Remember that we said all members of the same homologous series have the same chemical properties. So alkanes will have the same chemical properties of the same reactions. Now, one reaction of most organic compounds is burning or combustion. Combustion or burning means reaction with oxygen. Now, we have two types. Either we have a lot of oxygen or we have lack of oxygen. When we have a lot of oxygen, this is called complete combustion, and any organic compound that burns in oxygen, doesn't have to be alkane, could be alkene, could be alcohol, in a lot of oxygen, complete combustion will give carbon dioxide plus water. And always remember to balance any chemical equation that you write. Now, if we have a lack of oxygen, or we're burning something in a closed room where there is not enough oxygen, this is called incomplete combustion. Now, incomplete combustion will not give carbon dioxide and water, it will give carbon monoxide and water. And this is dangerous because carbon monoxide is poisonous or toxic. Now, if he says, why is it that carbon monoxide is poisonous? We say because it reduces the capacity of blood to carry oxygen. Remember that carbon monoxide is something that will attach to the hemoglobin in the red blood cells. If you've done biology, it will attach to the hemoglobin in the red blood cells. So the red blood cells will not be able to carry oxygen. So we say it reduces the capacity of blood to carry oxygen. Okay, another reaction of alkanes, and this is only alkanes. Nothing else will do this reaction. So only alkanes will do substitution reaction. Substitution reaction means I have an alkane, so such as methane, and I'm going to react it with a halogen. Remember that halogens are the ones in group what? They're the ones in group 7, fluorine, chlorine, bromine, iodine. Fluorine is very, very reactive. Iodine is not that reactive. So the reaction will either be with chlorine or bromine. And what happens is, from its name, substitution, we're going to substitute, or we're going to remove one of the hydrogens from the alkane, and we're going to put instead of it one chlorine. So instead of having CH4, I will have CH3Cl. And what is left is the hydrogen that I removed plus the other chlorine, so I am left with hydrogen chloride. So this is substitution reaction. Now you have to remember that this reaction will not happen unless if you give it UV light. So if he says, what is the condition for substitution reactions? It is UV light. And remember, don't write UV light unless if he's asking for the conditions. If he's just asking for the equation, you don't write the UV light. Okay? And of course, what comes out from this reaction, if I'm starting with methane, then what I have prepared is called chloromethane or bromomethane, depending on what I'm reacting. Okay? Oh, another reaction of alkanes is cracking. And cracking means breakdown of a long chain hydrocarbon into shorter chains. So I'm starting with something that has a lot of carbons like C8H18, and I'm going to break it up into smaller molecules. Now, when I break it up, I will always make an alkene. But I will either get alkene plus alkane or alkene plus hydrogen. So these are two possible outcomes from this reaction. So usually he will give you the reaction missing one of the products and you have to complete it. So if I start with C8H18 and then I break it up and I get one of them is C2H4, then what is the rest? The rest of the C8 would be C6 and the rest of the H18 will be H14. Now, the other question is, what is the condition, or what are the conditions for cracking? Now, for cracking to happen, I need to use a catalyst, aluminium oxide, or remember that Al2O3 is called aluminium oxide or alumina. And very high temperature, and you have to specify 600 to 700 degrees centigrade. So the conditions for cracking are, again, are you with me? Aluminium oxide catalyst or alumina catalyst and 600 to 700 degree centigrade. This will give me an alkene plus the rest of whatever I'm starting with. So he will give it to you to complete the equation. You should be able to complete the rest of it. Okay, what are alkenes? Again, we said alkenes are the ones that have C double bond C. And because they have C double bond C, we call them unsaturated. So if he says, why are they unsaturated? This is because they have C double bond C. The general formula we said is CnH2n, and that means that the number of hydrogens will always be twice the number of carbons. And always remember that alkenes are more reactive than alkanes, so they're going to do more reactions than alkanes. This is because it's easier to break the double bond and react with it than to break just the single bonds in the alkanes. So these are the alkenes: ethene, propene, butene, pentene. Now, reactions of alkenes, again, we said almost all organic compounds will do combustion. In presence of excess oxygen, it will give carbon dioxide and water, and then you balance based on the equation. And in lack of oxygen, you will get carbon monoxide plus water, and again, always remember to balance it. The other reaction of alkenes is addition. Remember that alkanes did what? Alkanes did substitution, but alkenes will do addition. So when we have an alkene, like this one, this was ethene. Now I react it with something. What happens is the double bond opens up and forms a single bond. And then I add something to this carbon and something to this carbon. So in this case, I'm reacting it with Br2. So the double bond becomes a single bond, and I put a Br here and a Br here. Now, when I'm told to name this, this is called 1,2-dibromoethane. When we have two bromines, it is dibromoethane. Now, what do we use ethene for? We use it to make ethanol, and we use it to make addition polymers, and we'll talk about that again later. How do we distinguish between alkenes and anything else? If you remember from the chapter on tests and qualitative analysis, we said the alkenes have the C double bond C, and that means that if I add bromine water, what happens to the bromine water? The color changes from reddish brown or orange to colorless, or the color of the bromine water is decolorized or changes to color. Okay? So let's see this question. He says a molecule of this has this formula. Explain which homologous series this belongs to. Which homologous series do you think this belongs to? First of all, it has only C and H, so that means it's either an alkane or an alkene. Which one do you think it is? Do you remember the general formula of each one? We said if the hydrogen is twice the carbon, then it is an alkene. If it is more than twice the carbon, then it is an alkane, because the general formula of alkanes is CnH2n plus 2. Okay? State what is meant by a hydrocarbon being saturated. We said saturated means what? It means that it has only C single bond C, or it doesn't have any C double bond C. Okay, describe a chemical test used to distinguish between unsaturated and saturated. We said the test here would be add bromine water. With unsaturated, the solution turns from orange to colorless. With saturated, there is no change to the color. Again, if you're asked this question, so these are questions just for practice. When methane burns, it reacts with a gas in the air. Give the name of this gas. So when methane burns, it reacts with what? We said it reacts with oxygen. Name the two substances that form when methane burns in a lot of air. So we said if we have a lot of oxygen, now the compounds formed are carbon dioxide and water. Name the poisonous gas that forms when methane burns in a shortage of air. We said if there is not enough oxygen, then which gas is formed? Carbon monoxide. Okay, will you be able to answer the questions after that? Good. Let's try one more question, then continue. So this question says the alkanes are homologous series of hydrocarbons. The cycloalkanes are another homologous series. So this is a kind of alkane, but it is cyclic in the form of a cycle or a ring structure. So he drew the displayed formula for cyclopropane. So how would you draw the displayed formula for cyclobutane? Remember that I did not explain cyclo anything, but he's telling you. So don't be shocked if you see something you've never seen before. You just apply what we said. We said each carbon must have a total of 4 bonds, and he wants C4H8, and he wants it in a ring structure. So it should look something like this. Okay. Another practice question. One product of the reaction between cyclopropane and bromine is hydrogen bromide. So he's reacting cyclopropane and bromine. So he's reacting an alkane with bromine. Do you remember alkanes with halogens? What was the condition? We said alkane, any alkane with hydrogen. This is substitution reaction, and substitution reactions need UV light. Complete the displayed formula for the product of this reaction. So if this reacts with bromine, we said in substitution reactions, what happens is one of the hydrogens is replaced by a bromine. So this is your product. Okay. Then another group of compounds is the alcohols, and we said alcohols all have OHs, so you can have any of these as an alcohol. Methanol, ethanol, propanol. Remember that if you want to be specific, you specify the number, which carbon the OH is on. And again, if the OH is on the end of the chain, either on this end or the other end, we count from the side that gives you a lower number. So this is not 3 propanol, this is 1 propanol. Because if I count from one end, it is 1 to 3, but if I count from the other end, it's just 1. And the rule says count from the side that will give the lower number. Okay, so this is again 1 butanol. Now this one would be, if I count from one end, it is 1, 2. And that's the carbon that has the OH. If I count from the other end, it is 1, 2, 3. So is this 2 butanol or 3 butanol? We said we choose the side that gives the lower number. So this is called 2 butanol. Do we understand that? Okay. So ethanol is a basic alcohol. This is what we call alcohol. The normal alcohol that is in beer or wine or things like that. So that is ethanol. It is used as fuel, it's used as a solvent, it's used to make beer, it is present in all your perfumes and so on. Okay, how do we make ethanol? We're going to make ethanol by 2 methods. One method is reaction of ethene with water. When I react something with water, this is called hydration. So reaction of ethene with water, this is hydration. And we said if I have ethene and I'm reacting it, how does it react? We said we open the double bond and change it into a single bond. And then I put something on this carbon and something on this carbon. The other reaction was with bromine, Br2, so we put Br and Br. But here the reaction is with water, so we're going to put H and OH. Okay, what are the conditions for this reaction? You have to remember. Can you memorize all these conditions? So when you add water, and the water is at a very high temperature, so this is in the form of steam. You add water to ethene, you need to give it what? H3PO4 catalyst. Do you know what is H3PO4? H3PO4 is phosphoric acid. So you need phosphoric acid catalyst, a temperature of 300 degrees centigrade, and a pressure of 60 to 70 atm. You have to memorize these conditions. So this is the first method of making ethanol. I make ethanol from ethene. How do I do that? By adding steam to ethene in presence of phosphoric acid catalyst, 300 degrees centigrade, 60 to 70 atm, and that gives me ethanol. Now, the advantages of this is that this is a very quick reaction, and my only product is ethanol, so my product is pure. Now I can make it, the problem with this is that where do I get ethene? We get ethene from petroleum, and we will discuss how do we get ethene from petroleum. But anyway, in order to obtain ethene, I need to be in a country, for example, that has a lot of petroleum. So in that case, they will use the petroleum to make ethene, and then from ethene, they add steam to make ethanol. The other method is used if I don't have petroleum. If I don't have petroleum, then I am probably not an industrial country. I'm probably an agricultural country. And in that case, I will grow sugarcane. From the sugarcane, I get glucose. So C6H12O6 is glucose. Now, I can put yeast and water at 35 degrees centigrade. This will change the glucose to ethanol and carbon dioxide. So this method is called fermentation. Now, again, we said there are two methods of making ethanol. I can either make it by hydration of ethene or fermentation of glucose. So in case of fermentation of glucose, we said I get glucose from sugarcane. Sugarcane is a renewable resource, and I need room temperature or just a little bit of temperature, and that is less expensive. The problem with the fermentation is that it is a slow process, and then when it gives me in the end, I have ethanol and water and yeast, and I need to purify the product before I can go. Okay, so let's try this question. The equation for this reaction is, in the direct hydration method, ethene reacts with steam. So it's talking about the reaction of ethene with steam. Do you remember which catalyst we said we're going to use in this reaction? Do you want to go back? Which catalyst? Phosphoric acid, which was H3PO4. So he says name, that means I have to give him name. State the temperature and pressure. Remember when I had ethene and I added water, we said we need phosphoric acid catalyst, and what temperature? You need to memorize that. 300 degrees centigrade. What pressure? 60 to 70 atm. You need to memorize these conditions. Okay. The other question says ethanol can be manufactured from ethene using reaction 1. So reaction 1 is the one we just talked about, ethene plus water. And ethanol can also be manufactured from glucose using reaction 2. So that is the one that you're going to put yeast on the glucose in order to change it to ethanol. Give two advantages of using each reaction to manufacture ethanol. Do you remember what were the advantages of adding water to ethene? We said, first of all, it's fast and it gives a pure product. We get only ethanol from this reaction. Now, the other one, we said we're going to use glucose, which is obtained from sugarcane, and sugarcane is renewable. And we said it does not require high temperature, so this is less expensive or it saves energy. Okay? Please listen to this video as many times as you like. Study the notes. You need to study this chapter very well. This is a very important chapter. Ethanol can be made by two different methods. Again, name the catalyst used in each method. So if we're talking about fermentation of glucose, you remember what we added to the glucose? We added yeast. And yeast, in it, it has an enzyme called zymase. So when you add yeast to something, the catalyst is the zymase enzyme present in yeast. Now, what was the catalyst when we added steam to ethene? Ethene plus water or steam, we used phosphoric acid catalyst. Okay, please study this as much as you can. Reactions of ethanol, again burning. Again, this will either give you carbon dioxide and water if we're talking about complete, or carbon monoxide and water if we're talking about incomplete. Now, oxidation is a reaction that we can do for only ethanol. So oxidation of any alcohol gives the corresponding acid. So if I'm doing oxidation of ethanol, it will give me ethanoic acid, or propanol will give propanoic acid, or butanol will give butanoic acid, and so on. Now, what are the conditions here? You have to remember the conditions are potassium manganate, KMnO4, is an oxidizing agent. It is called potassium manganate 7 in presence of concentrated acid, concentrated sulfuric acid. These are the conditions for the oxidation. Do we understand this? Okay, the other reaction that ethanol does is the opposite of dehydration. Remember we said we can add water to ethene to make ethanol. Well, we can get ethanol and change it back to water and ethene. This is called dehydration. If you're removing water from something, so here we're removing water from the ethanol, this is called dehydration, and this returns it back to ethene plus water. Now, what is the catalyst that I need? You have to remember again, alumina or aluminium oxide catalyst. So actually we've talked about aluminium oxide catalyst in two cases. Do you remember what was the other case where we said the catalyst is aluminium oxide? Well, if you go back again, you'll find that the catalyst for cracking was also aluminium oxide. Okay, so this is a possible question. He says this apparatus is used to convert ethanol into ethene, and he's changing ethanol into ethene. So what is the type of this reaction? This is dehydration. Remember, if I'm starting from ethene and making ethanol, I am adding water. That is called hydration. If I'm going the other way around and I'm changing ethanol to ethene, then that is removal of water. That is dehydration. And he has in the diagram that he's going to pass the ethanol over aluminium oxide. What is the function of the aluminium oxide in this reaction? Remember that we use aluminium oxide as a catalyst. Okay. Now, these are examples of acids. Again, one carbon will be methanoic acid. Remember to count the total number of carbons. Don't skip the carbon that has double bond O. So I have a total of 2 carbons, that's ethanoic. I have a total of 3 carbons, that is propanoic acid. Okay, reactions of acids. First of all, this is similar to any other acid. Remember when we're doing acids and bases, and we said acids will react with metals. So when an acid reacts with metal, it gives which gas? It gives hydrogen gas. Now, where is the part of this molecule now that is being replaced? Remember that it is this hydrogen. Can you see that? The hydrogen where we have C double bond O, OH, that's the one that we remove and put an Na instead of it. Okay, can you see what happened? So I'm starting with this sodium and an acid. The organic acid has C double bond O and then single bond OH. Now it is the H of the OH that has been removed, and I replace it with sodium. Okay, and then what comes out is called something O8. So if I started with ethanoic acid, I reacted it with sodium, then my product is called sodium ethanoate. Okay, again, this is a reaction between calcium and which acid is this? This is an acid that has 2 carbons, so this is ethanoic acid. Again, my product will be calcium ethanoate. Remember that the valency of calcium is 2, and that means I need 2 of the CH3COOs to bind with the calcium. Do we understand that? Okay. Now, again, when we were talking about the reaction of acids, remember with acids and bases, we said acids react with what? Then acids react with metals to give hydrogen gas. They can also react with carbonates to give which gas? Carbon dioxide. So again, this type of acid, the organic acid, will also react with carbonates. Again, I will give this plus sodium carbonate, for example. So what I get is sodium ethanoate plus what? We said any acid plus carbonate will give salt. So sodium ethanoate here is our salt. Plus what? Plus carbon dioxide plus water. Okay? Now, the other reaction of acids is with alcohol. If I have an acid and I react it with an alcohol, what comes out is called an ester. Okay? The group of the molecules here, of the compounds here, is called ester. So, which acid and which alcohol am I starting with? I'm starting with ethanoic acid, for example. I'm reacting it with ethanol. Now, what happens is this OH that is here will be removed. The H from the alcohol will be removed, and I join them together. Can you see what I did? Again, let's see that again. So, my acid has C double bond OOH. I'm going to remove the OH. And I'm going to remove an H. And then I'm going to remove an H from the alcohol and join them together. And what I end up with is an ester. Now, what would be the name of this ester? In order to name the ester, I start with the name of the alcohol. Which alcohol did I start with? Ethanol. Then my ester will be called ethyl something. Now, which acid did I start with? I started with ethanoic acid. Then this will be called ethyl ethanoate. Are you following? Let's try again. I'm starting with propanoic acid. I'm reacting it with ethanol. Now, what am I going to do? I'm going to remove the OH from the acid, remove the H from the ethanol, from the alcohol, and join them together. Can you see how I drew it? Okay. Now, once I've drawn it, how do I name it? We said I start with the name of which one? Of the alcohol. This was ethanol, so the first name is ethyl something. Now, the acid which ended with oic acid, it's going to end now with OH. So instead of propanoic acid, I now have propanoate. So my product is ethyl propan. You need to sit down and practice all of this. So this is what we've been talking about. Esters are the compounds that have C double bond OO something. So how would you name this ester? Again, which part is the acid? The first part is the acid. So the C with 3 H's around it. C double bond O. O, that was the acid. And the rest of it, that was the alcohol. Now, when I name it, do I start with the name of the acid? Or do I start with the name of the alcohol? I start with the name of the alcohol. So this will be methyl ethanoate. Can you see that? Let's try this one. Again, the part that says HC double bond O single bond O, that was the acid. And the rest that has the 2 carbons joined together, that was the alcohol. So which alcohol was it? This is something with 2 carbons, so that's ethyl. And the acid was something with 1 carbon, so that is methanoate. Can you name this? Okay, try naming this. The alcohol part, the last part, has 2 carbons, so that is ethyl. The acid has 2 carbons also, so that is ethyl ethanoate. What about this one? So the part with 4 carbons all behind each other, that was the acid. And the part that has the 2 carbons after each other, that was the alcohol. So that is ethyl butane.